In this question, we will work with a composite material which is made from type E glass fibers embedded in a matrix of ABS plastic. In part A, we will determine the minimum volume fraction of fibers, and in part B, we will estimate the elastic moduli, the shear modulus, and the major and minor Poisson's ratios for the given volume fraction in part A. At first, let's write the material properties. From table 5.2, we have for E-glass reinforcement, Young's modulus is 72.4 GPa and Poisson's ratio is equal to 0.22. And for the ABS matrix, we have Young's modulus is equal to 2.4 GPa and Poisson's ratio is equal to 0.35. We will also need the shear moduli, so let's calculate it by using the formula G is equal to E over 2 times 1 plus mu. So that we have G is equal to 29.67 GPa for E-glass and G is equal to 0.889 GPa for the ABS matrix. Let's start with part A. For X is the fiber direction, we have EX is equal to 55 GPa. It is given in the question. And we know that EX is equal to volume fraction of reinforcement times E for reinforcement plus volume fraction for matrix times Young's modulus for matrix. And we also know that volume fraction for matrix is equal to 1 minus volume fraction for the reinforcement. When we substitute the values, we get 55 GPa is equal to VR times 72.4 GPa plus 1 minus VR, which is VM, times 2.4 GPa. When we make the computations, we got volume fraction for reinforcement as 0.751 and VM as 0.249. And the minimum volume fraction as VR is equal to 0.751. We will move on to part B then. We will use the equations 5.64 5.65 and 5.66. We have that Poisson's ratio xy is equal to volume fraction for reinforcement times Poisson's ratio for reinforcement plus volume fraction for matrix times Poisson's ratio for matrix. Let's substitute the values again. Plus and we got nu xy is equal to 0.252. We know that nu xy over ex is equal to nu yx over ey. So we can compute also nu yx as 0.0402. Let's compute Young's modulus y, and we know that it is Young's modulus for reinforcement times Young's modulus for the matrix over, again, volume fraction for reinforcement times EM plus VM times ER. And we also have the data for these values, and we got EY is equal to 8.78 GPa. Finally, we will compute the shear modulus. We know that Gxy is equal to GR times GM. This equation is very similar to the equation for Young's modulus. And again, when we compute, we got Gxy as 3.28 GPa. And we are done.